Welcome! Today we're diving into a really fascinating and, let's be honest, sometimes frustrating part of our immune system. It's a reaction that's not about lightning-fast speed, but about a slow, calculated, and seriously powerful response. So let's start with a little mystery you might have even experienced yourself. You're out on a hike, you brush up against some plant, and nothing happens. But then, 2 days later, boom, you've got this incredibly itchy, angry rash. What in the world is going on there? Okay, let's get into it.
All right, so here's the game plan. We're going to start with what makes this allergy so different. Then, we'll meet the key cellular players, walk through the two-phase reaction, and see how it can be both protective and damaging. After that, we'll check out some real-world examples and finish by seeing exactly how type 4 stands out from the crowd.
Okay, first up, let's establish what makes this reaction so unique. You know, unlike those super fast allergies you might be thinking of, this one really plays the long game. It is all about the timing and the very specific responders the body decides to call into action.
So here's the core definition, and the two phrases you've got to remember are cell-mediated and delayed. This isn't some immediate alarm triggered by antibodies just floating around in your blood. Nope. Think of it more like a slow, deliberate military operation, run by specialized cells that can take a full 2 to 3 days to even show up.
So if it's not antibodies, then who is running the show? Well, let's introduce the main characters in this story, the immune system's very own special ops team.
See, it's not just one hero here. It's a whole coordinated team. You've got your scouts, the antigen-presenting cells, who find the invader. They report back to the generals, who are the T cells. And then the T cells call in the heavy infantry, the macrophages, to actually deal with the problem. What's so interesting here is how these roles all interact. It's a chain of command, and that takes time to get mobilized.
Now, this whole immune response unfolds like a two-act drama. You've got the first encounter, and then you have the rematch. Let's see how this whole thing builds over time.
So, there are two really distinct phases. First is the sensitization phase, which you can just think of as basic training for your T cells. The second part is the effector phase, and that's the actual battle that happens on every future encounter. And you know, this whole initial training thing is why the very first time you touch poison ivy, you might not get a rash at all. Let's look at this timeline. This first phase is totally silent and pretty slow, taking 1 to 2 weeks. The antigen, let's say it's the oil from that poison ivy leaf, gets processed by your scout cells. They then spend the next week or two literally training your T-cell generals to recognize this one specific enemy. Your body's basically creating a memory of the invader, and the wild part is you don't feel a single thing.
So, your T cells are trained. They're ready, they're waiting. Now what happens on the second exposure? Maybe you go for another hike a month later and brush past that same type of plant. Well, this is where the action starts, and it's way faster than that initial training phase.
This time around, your sensitized T-cell generals immediately recognize the threat. They release this whole cocktail of chemical signals called cytokines. You can think of these like messenger flares going up. They activate the macrophages, they start cloning more T-cells to build up the army, they cause inflammation to get more blood flow to the area, and this is crucial. They trap the macrophage soldiers right at the battle site so they can't leave. So, is this powerful response a hero or a villain? I mean, it's an incredibly effective system for fighting certain infections, but that intense, localized battle, it can come at a cost. It really is a double-edged sword.
On the one hand, this is a vital defense mechanism against pathogens that love to hide inside our own cells, like the bacteria that causes tuberculosis. The macrophage army is perfect for clearing those guys out. But, on the other hand, if that battle rages for too long because the invader is just too persistent, all those chemicals released by the macrophages can start destroying your own healthy tissue as collateral damage. And this leads to something really amazing, the body's attempt to contain a persistent threat. When the macrophages just can't win the fight, they change their tactics. They actually transform and fuse together, forming a wall called a granuloma to trap the enemy. It's this incredible defensive structure, but unfortunately, building it can lead to some significant tissue damage and scarring over time.
So this isn't just some abstract textbook concept happening on a microscopic level. It's the mechanism behind a lot of common and well-known conditions you've probably heard of, or maybe even experienced yourself.
I mean, this reaction is used on purpose in medicine, like with the Tuberculin or TB test, which checks to see if your T cells are sensitized. It's also the cause of contact dermatitis, that itchy rash you might get from a new piece of jewelry with nickel in it, or, of course, from poison ivy.
And even more seriously, this exact same cell-mediated process is involved in autoimmune diseases like type 1 diabetes and multiple sclerosis.
Okay, so to bring it all together, let's circle back to our original question. Why is a poison ivy rash so different from an immediate reaction like a bee sting? Well, the answer is all in the key differences between type 4 and other allergies.
Here it is, the crucial point. It's the difference between a cellular army and an antibody air force. Type 4 relies on cells, T cells and macrophages, physically moving to the site of the problem. The other types of hypersensitivity are run by antibodies, which are these tiny proteins that can trigger a much, much faster response.
And this table just lays it all out crystal clear. Look at the onset, delayed versus immediate. The mediator, T cells versus antibodies. And the mechanism, macrophage activation versus things like mast cell degranulation, which is what causes that rapid swelling from a bee sting. They're just two completely different strategies for dealing with a threat.
So if you only remember 3 things from all this, make it these. Number 1, this response is run by cells, not antibodies. Number 2, its defining feature is that characteristic delay. And number 3, it's a powerful double-edged sword that can both protect us and harm us.
And that leaves us with a final thought. The very same system that so brilliantly fights off tuberculosis can also cause the misery of contact dermatitis. It's this constant, incredible negotiation going on inside our bodies between defense and self-preservation. If you liked this video, then please like, comment, and subscribe.